Hi there. This flipped lesson is about how to use your mole calculations to work out either the enthalpy in a reaction or maybe the mass of stuff that might be used to create a certain enthalpy. So there's two sort of major ways they can go with this sort of calculation. We're going to cover both here. But essentially we're going to need to remember the whole mole calculation, and if you'll remember, Nigel the mole can be calculated by using the formula N equals M over big M. So remembering what each of these terms meant, this is mass and it's molar mass, and Nigel is the mole. And the units for these things is grams, molar mass is grams per mole, and moles is, you can just write with an MOL. Rightio, so here's a typical exam question. We've got a reaction of aluminium with iron oxide, and the reaction's given and supplied and it's already balanced. So we are noticing the mole ratios, like there's 2 moles of this to 1 of this to 1 mole of aluminium oxide to 2 moles of iron. And we're also noticing how much energy is released. We know it's released because it's minus the delta H, which equals exothermic, which means heat is released. Okay, so the reaction is telling us 2 moles of aluminium creates 1764.1 kilojoules of energy. We know that from the equation. So we're going to just draw up a wee table here, and we want to know moles. How many moles creates how much energy? And we know that as far as aluminium is concerned, from the equation, that 2 moles creates 1764.1 kilojoules of energy. Okay, so we've got that far. What we don't know is how much energy 44.2 grams will produce. So in this part A, instead of 2 moles creating 1764, they're asking us, we're only going to use 4.2 grams of the aluminium. So only 4.2 grams is used, and they want to know how much energy that will create. Okay, so that's our unknown. We want to work out how much energy a lesser amount of grams will create. So first off, we've got to figure out how many moles is this 4.2 grams. So we're going to use N equals M over M. So 4.2 is the little m, and we're going to divide it by the big M, which the questions provided is 27. And that equals, just off the top of my head, 0.156 moles. Okay, so now we've got an unknown and a known number of moles. We can turn that into a ratio. So what I mean by that is we can just go UC equals 0.01, forget that, 0.156 divided by 2. That's our UC ratio. And then we're going to times it by our known energy, and that's going to give us our unknown kilojoules. Okay, so if we do that maths, we end up with an answer of 137 kilojoules when we round it to 3 significant figures. And that's our answer. Okay, so now we have another sort of question with the same sort of problem. We've still got that same reaction, and we would have been given the delta H equals minus 1764.1 kilojoules per mole. So delta H's are always given in kilojoules per mole, and they have to be minus or plus because we're talking about a change in enthalpy. Okay, but in the question they're asking us they're telling us that instead of that amount of heat being produced, heat given off, we've got 89 kilojoules of energy given off. So in the last question we were given a different amount in the reaction of stuff, but in this one we're given a different amount of energy produced. So we can still use the same system. We're wanting to compare moles and how much energy a particular amount of moles creates, and we have our unknown and our known. Okay, so what we know and what we're looking at from the question, we're interested in aluminium oxide. So our known aluminium oxide from the reaction, looking at it here, we know that 1 mole is produced, it's one of the products, when 1764.1 kilojoules of energy is released. Okay, and instead of that amount of energy released, the question has told us that we've only got 89 kilojoules released, and we're wanting to work out first how many moles that is, and then we are told that we want to calculate the mass. Okay, so firstly we can use our UC ratio. So we know using what we know divided by what we don't know, and in this case we are doing that with the energy. Okay, we've got an unknown energy and we've got a known energy, so we can use this in our ratio. So we can go 89 over 1764.1. We can times it by our known moles to give us our unknown moles. And just off the top of my head, that is going to be 0.0505 moles. So now we've got this amount of moles, but we want to know how much mass is in that amount of moles. So now we're going to be wanting mass equals N times big M, and that's going to equal 0.505 times 102, which is the molar mass that we would calculate by using these molar masses supplied in the question, grams per mole, and that's going to give us our answer of 5.15 grams. Okay, so in both cases you just needed to draw up this grid of what we know and what we don't know in terms of moles and energy, and that's going to give you an unknown over known ratio, whether it's a ratio of moles or whether it's a ratio of kilojoules. Okay, now it's just a matter of getting some practice.